Hello, my name is Daniel Garcia and I'm going to present the evidence 1 about the Wheatstone Bridge circuit and e-waste in Mexico. Okay. For the final evidence, we were asked to produce a Wheatstone Bridge circuit. This was to relate a connection with e-waste and physical visualization of circuits. The objectives are to demonstrate how we can build a circuit, analyze its behavior, observe its applications, and describe its functionality. Additionally, we will identify a global issue of e-waste and relate it to an SDG, in this case SDG 12, which promotes responsible consumption and production. What is a Wheatstone bridge circuit? It is a circuit for precise resistance measurement. For this case, we used a 9-volt power source, 4 resistors in a diamond configuration, 3 were equal to Rx and 1 was our R test. We used a multimeter connected to the ports B and C to measure voltage and current, and the functionality is to measure the imbalance in voltage between the known resistances and unknown resistances. The Wheatstone bridge is a well-known electrical circuit used for precise resistance measurement. We built this circuit using a 9 volts. For the next part, we tested it with 4 different conditions. When our test was equal to 1 kilo ohm and Rx was equal to 10 kilo ohms, we measured 3.68 volts and 623 microamps. The smaller R test created a positive voltage imbalance. At 100 kilo ohms, the voltage reversed at negative 3.68 volts and the current dropped to negative 261 microamps, keeping the same Rx values, showing how larger R tests reverse the polarity. Then we short-circuited the circuit. At R test equals 0 ohms, it caused the maximum output to be 4.5 volts and 900 microamps. And lastly, an open circuit, where R test approach infinity results in no current flow, with a maximum negative voltage of negative 4.5 volts. Each test demonstrated how the Wheatstone bridge circuit responds to changes in resistance, giving us insight into its accuracy and precision. Some applications of the Wheatstone bridge are for precise resistance measurement in labs and industries. It's also the foundation for many sensors like strain gauges and thermistors, which respond to environmental changes. Additionally, it's used for calibrating components by comparing them to known standards. Lastly, it's an invaluable teaching tool because it allows us to visually interact and experiment with a circuit, as well as visualize how different resistances and differences in resistance and voltage will impact the measured amperage and voltage. Some shocking facts I learned over the investigation about e-waste in Mexico is that Mexico produces about 1.2 million tons of e-waste, and it's expected to increase up to 2.4 on 2026. And it's mostly from discarded electronics like smartphones, laptops, and televisions. Most of these discardments can be recycled and renewed into new electronic circuits, but only a small part is recycled. This leads to significant environmental degradation, including pollution, soil pollution, and resource depletion. Some key strategies that are currently being implemented in Mexico are collection events to provide safe disposal for electronic devices, more awareness and educational campaigns for proper disposal of batteries and electronic devices, specialized centers to recover valuable materials like metals and rare earth metals, awareness campaigns to educate the importance of this proper recycling and the dangers of improperly throwing away an electronic component. These efforts align with SDG 12, focusing on responsible consumption and sustainable production to protect resources and reduce pollution. Overall, this project helped me understand more about circuits, helped me build proper terminal connection, how multimeter works, and how a 9-volt battery impacts a circuit as a whole. help me analyze the usefulness of a Wheatstone bridge circuit, and I gained insight into its behaviors and applications, including its usefulness in precision resistance measurement. This technical knowledge also is useful for e-waste and sustainability because it tells me some key elements to know when trying to recycle these components and why they might need special treatment. Thanks for your attention. Here is a list of the references used.